Welcome back to 3 Inquisitive Kids. In this video, we will be applying the square difference formula and the perfect square formula onto some more practice problems. This is our second to last lesson of this unit, and it's called multiplying integrals. Our learning goals for today is to master the square difference formula and be able to apply it to simple problems, and use geometric diagrams to represent algebraic formulas. Introduction. Do you still remember what is the square difference formula? Well, we know that it's a plus b times a minus b, which gives us a squared minus b squared. I want you to use the square difference formula to compute these two expressions. This is a quick little warm-up. The answer would be 4x squared minus 49b squared and 9n squared minus m squared. Now I want you to pause the video and see if you can quickly calculate 201 and 199. Well, in order to do that, you can rewrite 201 as 200 plus 1, and you can rewrite 199 as 200, you guessed it, minus 1. And then now, having this expression, we could quickly use the square difference formula to help us calculate, instead of directly multiplying these two large numbers together. This is a geometric diagram representing the square difference formula. And here we have a little animation to show you. It's always nice when you can have visual thinking. So this length is A, and these lengths are B. And you can see we moved this small rectangle from here to here. This proves that a minus b times a plus b equals a squared minus b squared. This equation is telling us the area of the shaded blue parts. On the left side, our blue part is a plus b times a minus b. That's its area. So that's the left side of the equation. And then on the right side of the equation, we have a squared, a times a, minus b squared, this small gray area. But the area is actually still the same. That's how we got the equal sign in the middle. So here again, it's the same thing. We're calculating the area of the pink shaded parts. So in this case, it would be the area of the entire square, a squared, minus the area of this orange part, so b squared. So a squared minus b squared. And here on the right side, we've moved this bottom pink chunk to the top. So now its length is a plus b, and its width is a minus b, so it's a plus b times a minus b. And that's our square difference formula. This is a squared. This is a squared minus b squared. And here, this is another way to prove the square difference formula. We are using trapezoids. So this is actually the formula to calculating the area of a trapezoid. So a plus b times a minus b equals a squared minus b squared. There are a lot of different geometric ways you can draw out to represent this square difference formula. That's why it's so interesting. Algebra and geometry are always connected. So here's some application of the square difference formula. Observe the following equations. What pattern can you find? 8 times 6 equals 48. 7 times 7 equals 49. 16 times 14 equals 224, 15 times 15 equals 225, and so on. So what's a pattern you can find? You can see that here we're taking 8 and 6 and finding the number right in between them, which is 7. And when we multiply 7 by itself, we get 49. That's always one more than the numbers next to it multiplied. And here it's the same thing. We find the number in between 16 and 14, which is 15. We multiplied 15 by itself to get 225. That's still always one more than 224. So what pattern can you find? Does this have anything to do with the square difference formula? So I want you to use variables and express the pattern you found in mathematical terms. Can you prove that it's valid in any situation? Well, our answer would be a plus b times a minus b equals a squared minus b squared. If you want to, you can pause the video and list out another example for you to try out. So in this case, 7 is our a and b is our 1. The first term, 8, would be 7 plus 1, a plus b, times 6, which is 7 minus 1. Now we apply the square difference formula. We have 7 squared minus 1 squared, which is 1. That's 48. So that's how we got to 48 as our first answer. Here's some practice. I want you to compute these two expressions. I hope you use the square difference formula. 103 is equal to 100 plus 3. 97 is equal to 100 minus 3. Now we use the square difference formula. We have 10,000 minus 9, which is 9,991. For the second problem, we rewrite it as 120 minus 2 times 120 plus 2. We apply the square difference formula and we get 14,396. You first have to transform the expression a bit by yourself before using the square difference formula. So, of course, we couldn't just use the square difference formula as our first step. We first had to rewrite each term. I want you to compute these two expressions. Solution number 1. We use the square difference formula to get a squared minus b squared. Remember, we still have our parentheses around it. Then we apply the distributive property of multiplication, and we end up having two opposite terms which can cancel each other out, so we get a to the 4th power. The solution to the second problem, we use the square difference formula again. So that would be 4x squared minus 25, and we have to get rid of the parentheses. Negative 4x squared plus 6x. Remember, we had this negative sign on the outside, so you had to pay attention to changing the signs of the terms. And now we still have some things to cancel out. We're left with 6x minus 25. Karen leased a square plot of land with a side length of a meters to Kaylee. Karen said, I will reduce the length of this square by 4 meters and increase the width by 4 meters. Kaylee agreed to this change. Is this fair for Kaylee, and did she lose land? I want you to pause the video and see if you can use math to prove your thinking. So the area of the original square would have an area of a squared. After the change, when you multiply the length and the width together, it's a plus 4 times a minus 4. And when you use the square difference formula to simplify that, you get a squared minus 16. So you can clearly see that this is 16 square meters less than the original area. So Kaylee did suffer a loss. Expand your thinking. Here we have x minus y times x plus y times x squared plus y squared. I want you to pause the video and think about this by yourself for a little bit longer. This, in the end, is still an expand your thinking problem. The solution would be to first use a square difference formula to get x squared minus y squared. And then we use a square difference formula again to get x to the 4th power minus y to the 4th power. Our second problem is, given a equals 2 plus 1 times 2 squared plus 1 times 2 to the 4th power plus 1, the value of a is blank. So here is our solution. You can see that this is our original expression, and I will highlight that out for you here. That's our original expression. And we multiplied on an extra 2 minus 1. But it's alright because in the end, we also divided that extra 2 minus 1. So we're actually coming up with something by ourselves. And we added that extra 2 minus 1 on for a reason. It's so we can use the square difference formula. 2 minus 1 times 2 plus 1 equals 2 squared minus 1. And then we apply the square difference formula again with these two binomials. We get 2 to the 4th power minus 1. And now we're left with 2 to the 4th power minus 1 times 2 to the 4th power plus 1, which gives us 2 to the 8th power minus 1. But remember, we still had that 2 minus 1 in the back that we had to make up for. So the value of a is 2 to the 8th power minus 1. Today we apply the square difference formula onto problems, and we looked at some geometric representations of it. The formula itself is a plus b times a minus b, which equals a squared minus b squared. And we know that the square difference formula can only be used if two binomials are multiplied. If your expression does not have two binomials multiplied together, you have to first change it up yourself a bit to apply the square difference formula. I hope you enjoyed this video, and I'll see you in the next lesson.